Tonight's notes are going to be on similar triangles. Similar triangles, and this is on page 16. So let's start out with the definition. If two triangles are similar, they have congruent corresponding angles. And corresponding sides are proportional. Now there's a few words I want to highlight in this. The word similar, because that's what we're learning about. So similar. And then we have congruent corresponding angles. So in similar triangles, the corresponding angles are going to be congruent. And then corresponding sides are proportional. Now let's talk about this word proportional. So proportional means there's a ratio, which we learned we can call scale factor, between them. So there's some type of scale factor between those corresponding sides that can get you from one to the other. That's what proportional means. So we are going to go over the similarity theorems that go along with proving that two triangles are similar. So the first one is angle-angle. So these may look similar to the ones that we talked about for congruence, except we've never had an angle-angle one. And we write this as angle-angle with this little swirly guy. And that right there is the symbol for similar. So angle-angle. That means that if we have two angles, two corresponding angles congruent, then we know that all three are congruent by triangle sum theorem. And that means that the triangles are similar. So let's just draw a quick example of that. Let's say we have that, for example. Those are corresponding to each other, this one and that one, that one and that one. They are congruent, which means we do have similar triangles. And I'm just going to write a little note over here. Which is what I said before. If we know two angles are congruent, then we know all three are congruent. By triangle sum. Okay, and let's just talk about why. Well, if this, let's just pretend like this is 14 and that's, 62, then we can find that angle and it would be something. And if we did the same thing over here, it would be that exact same degree measure. Because if we have two, we can find that third. And if all angles are congruent, then we definitely have similar triangles. So that's the first one. The next one is going to be side angle side similarity. And this is written as side angle side similarity. It's really important to make that distinction because these are not necessarily congruent triangles. These are similar triangles. And it could look like this. And we are not saying that the sides are congruent. Remember, in our definition it says the sides are proportional. So for example, let's say this was x and this is y and we have this angle the same. This is not going to be x because they're proportional, they're not congruent. So this could be something like 3x and this would be 3y. Since you can have a scale factor going from x to x and y to y, that same one, then you know that this is similar. And I'm going to write that down. I'm going to say the two pairs of corresponding sides are proportional. And the angle between is congruent. So again, these are not congruent sides. Well, they're not necessarily congruent sides. There's a scale factor here going from that triangle to this one, and it's the same one going from those sides. So that makes it a similar triangle. And then the last similarity theorem that we have is side, side, side. And again, this is side, side, side similarity. It's not congruent. So that does not mean that you have three sides congruent. You have three sides that are proportional, which could look like this. Where we could have side length x, y, and z. And then this could be 4x, 4y, and 4z, because we have that scale factor going from the first triangle to the second one. And I'm just going to write all sides are proportional. And I should have written all corresponding sides, so I'm just going to go like this and write corresponding here. All corresponding sides are proportional.